More educators are learning of the vast cognitive functions of the brain and planning their lessons according to these to have a more applicable and efficient learning process for students. Several examples of these functions are working memory, attention, mental flexibility, self-regulation, planning, inhibition, and organization. One of the most important cognitive skills for students is working memory due to its role in improving their achievement in school. Working memory is a subcomponent of an overarching cognitive skill of memory alongside other components of short-term memory, sensory memory, and long-term memory. It is briefly known as the small amount of information that can be held in mind and used in the execution of cognitive tasks. Working memory is employed in concept formation, control processes, mnemonic strategies, sentence recalling, spatial, verbal, and arithmetic domains, which shows it is an important component to ensure the efficiency of students' learning process. As working memory is acknowledged as an important component in learning, there is an emergence of multiple interventions devised and utilized for specific settings. There are three main types of methodologies practiced by children aged 4 until 11 years old in the classroom. They consist of environment adaptation, direct working memory training with or without training instruction, and indirect training skills such as phonological awareness and physical activity. In addition to the above mentioned, there are also computerized interventions of working memory. Educators' objectives for the students remain the same, which is to produce near transfer effects, far transfer effects, and generalization, which can be achieved by different interventions. Nevertheless, there are several obstacles that might surface in their implementation. Educators are required to address attention first prior working memory to properly conduct classroom working memory interventions, whereas heterogeneity is evidently present in conducting computerized working memory interventions, leading to indefinite inferences. Thus, the current research is proposing another methodology, which is the utilization of binaural auditory beats in modulating working memory. Several past studies have been conducted to observe individuals' cognitive function of memory, such as working memory and long-term memory. These studies were conducted in samples of populations from different countries, such as Spain, United States of America, the Netherlands, and Germany, whereby the common age range of participants were from 18 to 40 years old. According to these studies, there is still yet an opportunity to observe the modulation effects of binaural auditory beats towards the working memory abilities of the Malaysian population, specifically young adults. Most Malaysian young adults embark on tertiary education of their choice after completing secondary education, while pursuing other activities such as having a career, honing life skills, and networking, in which exert an excessive demand to the working memory function. The aim of this study is to investigate the effects of alpha binaural auditory beats on working memory of young adults using the automated operation span task. According to a study, participants who consisted of young adults showed better working memory performance after a neurofeedback training that specifically improves upper alpha frequency band. Additionally, another study observed that alpha brainwaves can be increased by decreasing beta brainwaves, in which this process produced an improved state of memory. Based on the above mentioned, these studies have provided explanation that alpha brainwaves can be trained and increased to better the specific cognitive domain. Furthermore, it is also of interest to investigate the possibility of the auditory beat stimulation in education and working environment, as there is still opportunity in applying this technology in real-life situations which can directly benefit the community.
Working memory. The brain's working memory refers to the human memory system which temporarily maintains, stores, or manipulates information for cognitive tasks such as learning and reasoning. Working memory is a limited capacity system because it can only keep a limited amount of information in a short period of time. Working memory is different from short-term memory because short-term memory typically refers to remembering information for a short time, usually in a few seconds. For example, People's name or phone numbers will be forgotten if it is not being rehearsed. The same goes for when we are remembering the route to a certain direction. Thus, the process of repeating the information and carrying out the task relies on our working memory. There is a close relationship between working memory and long-term memory. Long-term memory refers to our childhood memories or the knowledge that we have acquired and remembered over the years. For example, the facts about the country, family history, or mathematical knowledge and grammar rules. Next, working memory is important for various complex tasks such as reading comprehension, mental arithmetic, and word problems to basic tasks such as copying notes in the class. A variety of strategies or training could help to improve the working memory capacity, which might help individuals to perform at their best. Now, let's move on to the binaural beats on working memory. There are several studies that have shown the relationship between the binaural beats and the memory. First, binaural beats are described as an auditory perceptions that are presented separately on the left and right ear by the two tones of slightly different frequencies. A study by Cross and Parabanova has shown that the brain activity changes automatically if the binaural beats match the frequency that corresponds to the alpha wave spectrum. Next, binaural beats could also affect various aspects of cognition or mood states for an individual such as attention, memory, creativity, and alertness. Besides, it is also an efficient way of increasing long-term memory in order to retrieve, identify, and enhance the encoding of new data. There are several factors that affect the binaural beats on cognitive functions, such as the specific frequency of the binaural beats, the targeted population, and the methods used to detect the possible improvements in working memory ability. The target group is important because the level of brainwave activity in older people is different from young people. Moreover, binaural beats may have a beneficial impact on retention, attention control, as well as the storage and the activation of information. Thus, it is shown that binaural beats have a relationship on working memory.
Next is binaural beats versus non-binaural beats. The usage of binaural beats allows different regions of the brain to be activated significantly by disparate simulations of sound frequency detected in binaural beats. There is a high possibility in boosting cortical synchronization aside from stimulation in the hemisphere, which leads to improved brain processes. Furthermore, it is said that application of binaural beats improves cognitive processes, provides sensations such as relaxation, altered conscious states such as producing lucid dream, as well as improving one's creativity. Non-binaural beats, on the other hand, includes vocal melodies or musical beats that are translated into sound waves and assisted by lyrical melodies that synchronize with the musical sound waves. Different voices of different pitch have significant advantage in memory enhancing. The influence of vocalization reflects a higher rate of arousal, where female pitch has higher memory influence compared to male due to emotional influences. In contrast to vocal melodies, binaural beats does not include female and male pitch influences on human emotions. Instead, it influences different brain area activation according to the low level of sound waves. Hence, studies on the binaural beats enable studies of sound wave on memory without the interference of other variables. According to Bedley and H in 1974, working memory holds information temporarily in the mind, enabling us to perform a variety of cognitive-based tasks. To assess working memory, complex working memory span or operation span tests can be applied, as this method requires individuals to remember a set of details in the correct arrangement, with the interceding of secondary processing tasks such as completing equations. The O-span task is notified as a task to predict intelligence, as it involves the process of information manipulation and memorizing in problem solving. Working memory span tasks usually involves a simple span task around 3 to 5 items and having an average of 5 to 9 items maximum for complex span memory tasks. It applies mnemonic strategies such as information chunking processes, which enables tested individuals to group stimuli together in smaller independent units, which is easier for the brain to capture or memorize. This results in the suggestion of simple span tasks in measuring working memory, as it is dedicated to item memorization and is rather a passive process.
This study will be done with 8 young adults aged between 25 to 29 years old. All participants are working adults and are healthy in terms of hearing ability. None of the participants is wearing hearing aids or has tinnitus. Tinnitus is an auditory phantom sensation, or in other words, ringing in the ears, felt when there is no external sound present. Operation Span Task is used to measure working memory capacity, and in 2005, a computer-administered Operation Span Task, which works automatically, was developed. In the Operation Span Task, participant needs to solve a mathematical operation and remember the presented letter after. This task will be repeated for 3 to 7 times. Next, the participant will be asked to recall back the presented letters in the right order. Next, the participant will be presented with feedback that shows the success of the task, how many letters the participant is able to recall correctly. From the automated operation span task result, the first score, which is the Ospen score, shows the total of all correctly recalled set of letters in the correct order. For the purpose of this study, this first score will be used most in the analysis. It is a score which is stable in terms of test-retest reliability when you're repeating the test after few minutes, weeks, or months. Binaural beats is a subjective auditory sensation when two tones with slight difference in frequency are presented to each ear separately. Hearing to binaural beats, a listener will hear a resultant sound with an amplitude which change with a frequency equal to the frequency differences of the two presented tones. When perceiving two tones with subtle differences between them, the brain will pick up the difference between the two frequencies, and the brain will hear this difference as a binaural beat. A software program called Audacity will be used to produce two tones, which are 230 Hz and 220.45 Hz. The difference in these two frequencies is 9.55 Hz, which falls in the alpha frequency range. This binaural beat will help to stimulate alpha waves in the brain. Alpha waves are associated with being in a state of relaxation while being awake. Two types of recording will be used in this study. The first recording is the sound of the sea overlapped with binaural beats, while the second recording is the sound of the sea without binaural beats. Day 1, the participant will be asked to take the automated operation span task. After the completion of the task, the participant will be given to listen to the recording with binaural beats for 12 minutes. After those 12 minutes, participants will be asked to retake the automated operation span task. Day 2, the process is the same as day 1. However, instead of listen to the recording with binaural beats, after the completion of the first automated operation span task, the participant will be given to listen to the recording without binaural beats before retake the automated operation span task. As for the expected outcome, the improvement in working memory capacity is expected as a consequence of alpha range binaural beats stimulation. This study can contribute to the number of studies on the effects of binaural beats, which is low, as well as further support the theory that binaural beats does improve memory. The results on binaural beats effectiveness can be used to enhance and maintain greater cognitive performance by implementing binaural beats into daily regimens such as yoga, meditation, and exercise.